Do you want to learn how to model wings in Rhino for aircraft, radio control aircraft, general aviation, whatever you need? This video will show you how to do it, so stay tuned. All right, jumping into it. This is an aircraft I've modeled up in Rhino already just to show you some capability. It has elliptical dihedral, so it's like continuously curving up. It also has a Scimitar profile. So this is designed to be 3D printed in sections, and on my website you can check out, here's the real thing right here, so it's gouldAero.com. I'll put links in the description below for this, but this is showing a 3D printed plane I call the Bronco, and it just goes over everything on here. And it's actually printed up. It hasn't been completed yet, but all the pieces are there, so it's showing what it actually looks like right there, and it's based off of a radio control airplane I designed over 20 years ago. It's conventional, balsa wood and nitro motor. So it shared some DNA with it, but this is all the new tech is printed on my Ender 3 Neo Max. So again, here's the file, and then going into a blank session of Rhino, we're going to show you how to start modeling airfoils, and you can create your own airfoils from scratch. For some basic things, but one of the better things to do is get on Google and check out PDAS Airfoil, and you'll see this website come up. Let me back out of that. Just PDAS Airfoils. The website is pdas.com, and that's going to take you into various, I'll just click on it. So you'll get a page like this, and it'll take a little bit of navigating, but here's one of the really good pages within it. So this one gets you the 6 series of NACA airfoils developed way back in the 30s and 40s, and these are still used on all kinds of aircraft. You can look up the performance data on these depending on what you need with further whatever you call it, Google searches. There's also a really good book I'll put in the description below called Theory of Wing Sections that covers some of this stuff. But for example, most of my flight time is in the Piper Cherokee, the PA-28. Right here is showing what this guy looks like. So a lot of you are used to this aircraft, and it uses a 6 series airfoil. So right there, it's a NACA 65 415. That sub little 2 right there means it has a droop on the leading edge for stall characteristics. I also worked for Piper for a couple of years too, so very familiar with this aircraft and the airfoil. So jumping into it, you can either do a keyword search with Control F within this website and look right here. You type in 415. Takes you there, or if you scroll up to the top and you go to the 65 series, you'll get right here. So what we're going to do is we're going to highlight all the coordinates, like so, or ordinates is what they call them, and then you'll get an Excel file, and we'll paste it, and we're going to, let's see, jump right back to it real quick. So the first 2 columns is the upper surface, and then the next 2 is the lower surface. So that's important to remember just for naming here. In theory, you can loop it all around in one shot, but I kind of like to do it in an upper and a lower, just so you can get leading edge and trailing edge discrete lock-ins for setting up your profiles at the leading and trailing edge. So here is all the coordinates. I'm just going to go over and grab my file where I want this to go to. So this is an Excel, and what we got to do is turn this into a CSV file. So we're going to do a save as, browse, and we're already set up there. So we're going to call this a 65-415 upper for the upper surface, and then we're going to change the type to a CSV. So that will save it. No, cancel, and we'll go delete all this stuff. Or we can actually, let's see if we can do so there we go. We can also do a Control Z for an undo, or you can go back and grab them again. So we're going to cut these. This is the lower surfaces now, or lower surface profile. And just showing you how it works, it goes from 0 to 100 here, and that is going to be along the chord, and then this is going to be the height. And also, if you get confused by upper versus lower, the lower will have negative values on the height or the vertical axis of this profile. So we're going to go over here, we're going to save as, browse, change it to a CSV first, and go and grab that same name, and we'll go with L for lower. And no, cancel, don't need any of that stuff. So anyway, we'll delete all that for now because we'll come back later and get another airfoil. So here we are in Rhino, brand new session. This is Rhino 8. I've gone over Rhino before on this channel, so this is my go-to personal CAD software, and it's very powerful. Of course, by coming to this video, you're interested specifically on how Rhino does its stuff, but let's see here real quick. So we got here under the drive of where these files ended up, and we'll go check out the upper file first. So how you do this and use it is you're going to right click, open with Notepad. Brings up the Notepad. So this is the upper surface, and just with some testing, getting back up to speed with all this stuff. Here's the CSV file, so it's comma separated values, and if you look at it, it has 2 commas behind each point on here, and that won't fly in Rhino. You got to get rid of those last 2. It's a formatting thing with this particular one, the upper, but it wasn't with the lower for some reason. So anyway, just going through, and there's other ways to do this, I'm sure, if you're savvy on CSV files and Excel. Got to make sure that you don't manipulate the data, though, when you do this, because it'll screw up the airfoil. So this is showing you real time. This is just me clicking behind it and deleting twice to get rid of all this fun stuff. We can even save it. So it's saved. So we're going to go and highlight all of it. We're going to do a Control C for copy. And then here under the standard tab or menu, you're going to have your different kinds of like making lines, making curves. And you're going to want to choose this guy, which is curve with the points. So they got one here with like steering curves, and then this second choice, one to the right, gives you precise points. So the menu is open, and you just go click up here in the address bar, and you do a Control V for paste. You can see it made the airfoil, and you right click what I did there to get out of it because it still wants to be hunt for new points. So we have all that, and then we're going to go to the lower file, same thing, open with Notepad. It's opening up on my other screen, but anyway, for some reason, the lower file, probably because nothing was to the right of it, doesn't have those commas. So this one's all good to go, but if it does have those commas and you try to enter it, you're going to get gibberish. Nothing's going to happen. So you're going to highlight all that, copy it, go back here. And because Rhino's really smart with its commands, you can just do a right click and it's going to bring back that spline command first. This is like a through point exact spline is curve, like interpret curve, INTERPCRV, that's the name of the command. Or again, it's the second to the right here in the menu. So we're going to do the same thing. We're going to paste. And you can see it's on the trailing edge. It's looking for some kind of conclusion. And that's a right click. So that makes our airfoil. Now we're going to show you some techniques here on how to handle things like maybe a Spitfire elliptical profile or something of that nature. But if you're just doing something quick and dirty, and of course you can always rotate the axis to different conventions. I'm pretty sure like X is the yaw axis, and or sorry, Z is the yaw axis, and then Y is the pitch, and then X is the roll. I'd have to go back to the design books. It's been a while since I've looked at that stuff at Embry-Riddle way back in the day. But if you're just going to do a Hershey bar wing, you can do with sheet bodies. Use the extrude straight command. We'll highlight it. And then this is trying to send it out in both directions. We can go direction. Let me cancel out of that and redo the command. Both sides, yes, is off, so now it's only going to go one way. Now remember, this airfoil is 100 inches long right now, and of course you would scale that, but just to show you how quickly this can be done. So 100 inches, right? So let's just make this thing 300 inches. And now it's there, and we will right click, and it has been created. So if you're doing like an RC plane, this is just showing like high level what this would look like. There's airfoil rendered. And we'll get out of that back to shaded. We'll delete it. And of course, I made an upper and a lower surface. And then we'll show you another command here. This is not getting into the scaling yet. This is just showing how everything works. If you do a join command, J-O-I-N, and you go click upper and lower, it made it into a complete loop. So it's basically a watertight sketch. And we go over to solid tools and do extrude on this, and same story. I haven't done it yet in this demo, but this should make a solid airfoil. So same 300-inch airfoil. It has ends. It is watertight. And then this is basically treated as a solid at this point. So you can go from there. You can also, if you want to break it apart, you can do an explode, which is this command is literally just explode. Click on that, and now the ends and the top are different. But because we made the sketch watertight, let's see here. Actually, that didn't make any difference there. So with the explode, it made an upper surface, a lower surface, and two ends. We'll undo that, and we'll just delete this. So the next thing is getting into this is scale. So let's see here. We'll just keep them joined for now. Let me try something real quick with a line. That's working. I'll turn the grid off and go back to line. So even with the grid off and snaps off, if I go choose any kind of line spline, it's still recognizing that leading edge as something I can be locked onto. And the trailing edge, even though this thing is a complete watertight sketch. So we have all that stuff. Probably turn grid back on. But again, this thing is 100 inches long just based on what the inputs were, right? Let me get back to the coordinates. So we're going from 0 inches all the way up to 100. This thing is in inches. So if you go in millimeters, it's going to be 100 millimeters long. And that's how you bring it in. It's best to just bring in the data straight and then do scaling inside of the CAD file. It's all done in one shot, and you don't want to be scaling within Excel or something like that. That's just a bunch of extra work. So let's say here. Let's say we want to make this thing like, we'll do like an actual, like light sport, general aviation kind of wing here, and just throwing out like 100 inches is beyond 8 feet. That's kind of ridiculous, but for, maybe for like a 10-seat aircraft or something like that. But let's just say it's 55 inches just to throw a number in there. We're going to do scale, and we're going to select the object to scale, and then where is it scaling from? And we're going to go here, and we're going to type in 0.55. I'll show you how that works here. So it's scaled it down, and what that is, whatever number you need. I'll pull up a calculator. Or actually I have Excel open. We'll go with Excel. So we're at 100, right? And you need a 55-inch chord is the goal, right? That's what you're trying to get at the root chord. So we're going to do 55, or sorry, got to do this backwards. So we're going to do 55 divided by 100, 0.55. So that shows you where that scaling comes from. It's usually best to do it on Excel or a calculator if you need something more precise, but of course being divided by 100, it's basically just moved the decimal points over a couple places. So now we got our 55-inch NACA 65-418 airfoil. And let's see here. Because I chose the right axis to define it, is it right, forward, or top? I chose the top axis to do this. So we'll show you some more commands here. And just thinking about it for a second. Let's just say definitely Z is usually up in an aircraft. So we're going to take this guy and we're going to do a rotate command. About here, and we're going to start looking. That's the long one. Here's the front. And you can see there's more chord over here than there. So with this particular airfoil, the camber, it's conventional cambered airfoil. So we're going to click on the right and we're going to rotate her up like that. So it's been rotated. Now, if you look at it, the Z-axis is here. It's pointing up in the right direction. So let's just say that we want our tip to be like 30 inches or something like that. And we're going to just set this straight out. So let's go grab a line. So we're going to make like a Scimitar wing, just like the Bronco 3D CAD file. So I've clicked on the trailing edge. I have a line. I'm going to press 300. And now it's going to act yeah. So just send it in that direction. Right click, it ends it. Of course, that's kind of huge. Let's do some simple math here, like a 25-foot wing, right? So we're going to do 25 feet. And time, because I'm in inches here, so I got to do 25 feet times 12. 300 inches. So that's like full span, just for simple numbers. I was trying to do a 3-to-1 in the 100-inch chord example. So you take all that and you divide by 2. The half span is 150 inches, which would be 12.5 feet. Just keeping this thing reasonable for scale. Of course, you'd be working off some numbers or figures, something like that. And then this, once you have all your data, like this is the airfoil, this is the chord length, this is the span, you'd be working from that. So got 150. And so I typed in 150 and I was not in ortho projection, which is aligned to one of the vectors. So now it's hunting and but I have grid snap on. And if I were to turn ortho on, it'd be locked there anyway. It's a little confusing. They'll turn ortho off. So there it is sitting. There's 150 inches going over. And then let's just say we want to do a 30-inch tip chord, and the tip chord is straight on this airfoil. So same thing, 30. So it's hunting around and we have locked it. Now we want to do an elliptical chord is our goal here. So we're going to come back here. We'll pass whatever you call it, y equals 0, and we'll come over here like so. I got a trim plane. I won't use a trim. Let's see, we're going to make an ellipse. So ellipse center is there. And the tip is here. And we're going to zoom in on this sucker. There we go. So there's our profile, like so. I'm going to do a trim, T-R-I-M. And we're going to choose the center line right there, and then this reference axis, right click, click it, and now we have our quarter of an ellipse for a Scimitar profile. So we're going to get rid of these two. Don't really need them right now, so let me do top view. That shows you what the wing is going to look like. Now let's just say we just want the same 65-415. Let's see here. I'll show you this way. We could always bring that, could have made a copy of the 100, bring it over here and so forth. And again, we're at 30 inches on the tip chord, if I remember right. Yep, 30. So I'll show you another technique here. Copy our first airfoil. And we'll bring it over and align it at the tip, just because as the Scimitar goes around the leading edge corner right here, it kind of a little harder to see. So we're at 55 inches. We need it to be at 30 inches. So we'll do the same thing. We got our 55. We got our 30, like so. You can use, a calculator, same difference. But we're going to do 30. We're going to do divided by 55. So that is our new scaling number. So I've copied it, and I come over here and I do scale. I'm going to scale the airfoil by the trailing edge, and I'm just going to type in, let's see if it doesn't like it for some reason. Let's see if this works. It is not liking that. So I will go screen over here. For whatever reason, it doesn't want to do something. We will type it in 0.54. Could even try the 30 over 55 as a fraction, 30 divided by 55. There we go. That did it directly. So you can also do division directly inside Rhino like so. And then we're going to explode those airfoils again. So there we go. So now we should have a top. We have a bottom on all these. Now this command that will make a surface that will follow the leading edge, trailing edge, and the contour of the airfoil is network surface. So it's NETWORKSRF. And as you start typing these commands in, they'll show up here on the command line. So it's going to be an enter, and that's just going to be a simple click the bottom, trailing edge, bottom, leading edge, enter. You got all that, and then right click to repeat command. So the top, trailing edge, and you want to choose the curve, and then the the root airfoil, and then the leading edge, and again curve. Right click, okay. So there is the airfoil right there for that Scimitar styled airfoil. You can do more advanced stuff with the tips and things like that. I'll go into rendered. So there's our airfoil. You can close it out, do all kinds of things with it. But we're going to close all that, and we'll go into another airfoil here. So we're going to keep the same, everything here is going to be the same, and then the next step in this journey. Looking back at it, we're going to, for this tip airfoil, we're going to use a 63-618. It's used on a 233 glider, and it works out very well. So let's go up to 63-618. We'll highlight it like so. So it's all highlighted. Go back to the CSV file. So we'll bring it over here, and we'll get rid of these guys. Do file, save as, to a CSV file. And this is an upper 63-618 upper. Been saved. We'll cancel out of that. Cancel. And we will undo it like so. Grab these upper coordinates, paste them, and we'll do a file, save as, browse, and let's see here, we've got the CSV file, and 618 lower, save. So that has all been saved. Get out of that stuff, delete it, and we're going to go over back to the CAD system real quick. So here's our airfoil. So let's see here. I'm going to get all this stuff out of the way, move it forward. We can always bring it back. You'll see how it's done. Let's see here, going back to the airfoil. Okay, so we want the 618 upper. We'll do open with Notepad. And I did the same thing with the double comma, so we got to back all that out. And remember, don't manipulate any of these numbers or it'll screw you up. So there's everything. We'll save it. Save. Highlight it. and we'll go into front. So yeah, that's the view you're going to want. We'll go back into that same curve command, dump it in here. So that has made the upper surface. And now we got to go into the lower surface. Make sure to open with Notepad again. Highlight everything, right curve, paste it, and it has created everything. So there is our airfoil. And remember, this tip is 30 inches. So we're 100-inch reference airfoil. We need it at 30 inches. So we're going to do a scale. Not that though. We want just this new airfoil. About the leading edge, and we're going to do 30 over 100. Directly typed in, and it shrunk it for us. So we can take this and we'll just shift it around with the gumball, and we're going to grab the wing and should be able to line it right back up because we're on grid snap, so it's moving this thing at 1 inch at a time. And that's what the grid is set to. So we got to move MOVE the tip airfoil, the new tip airfoil, over here. So now we have an airfoil 65-415 at the root. Its thickest part is near the middle. That's what that number means. It's like 50%, and then 63-618, it's going to be more like 30% right here. So we're moving the thickest part forward. We're putting more camber in it. We're making it thicker in total. So these are all dials to turn to basically increase the coefficient of lift, especially on the tip to help with like tip stall, things of that nature. So we're going to go back to network surface, click the bottom, same routine again. We got our lower surface, and then we'll go through the same thing. It's usually good to press the curve rather than the edge of the surface. So you're going back to original geometry, curve again. And there we are. So that is our airfoil. That is Scimitar and Profile, and it has a thickened tip on it. That's common with tapered wing aircraft. So that's just showing how all that works. There's your airfoil. Go back to shaded. Now there's other tricks here. You can go and make the leading edge curved, or sorry, the dihedral. So there's a lot of trickery going on here. I can show that in another video of how to make this continuously curved up. Of course, that'd only be worth it with like CNC equipment, or, you know, of course, a 3D printer is CNC equipment, but something of that nature to make it easy. Usually aircraft, they might have it be elliptical wings, but the panel is fairly straight most of the time. You could also put some twist into this, but this is kind of like a 101 video. We might do that in a follow-up video. So just looking here, what can we go over next? The next thing with airfoils, the way these NACA airfoils are designed are to a perfect razor blade trailing edge. So that is not realistic in the real world. So we're going to want something like, I don't know, 1/8 inch thick on the end. And we'll come into here, and we grabbed this trailing edge of the root airfoil. We'll go to the front, orthogrid on, so it's only going to go up, just to make it easy, and we'll go to 0.125. We're going to make like a 1/4 inch thick trailing edge. So that's there. That may not have worked like I wanted to. I'll redo that. So if I get it just right, I can do 0.2125. Yeah, it's not going to work right. Go to the front. There we go. So it's put one there. And something happened goofy to me. Oh yeah, I deleted the trailing edge. Sorry for that. Just see an easier way to do this. I think I'll take this tip cord and I'll move it. And then I'll just go to the, there we go. This will make it easier. So back to 0.125. it's there, and 0.125. So now we have that on the trailing edge. And if it's going to be, you can repeat the same stuff for the tip. Move to there, and we're going to copy. Oh man. We're going to copy these two little tick marks right here. We're going to need them. Copy. Zoom it out and go here to this guy. All right, so we now have these set up. And we're going to probably think of, let's see here. Normally what you would do is you go, and they usually will split the difference with this right on the trailing edge. So we can go grab that line, turn off ortho, turn off grid. Now we need tangent on here. So we got to turn on tangent. If it hunts for it, there we go. There's tangent. So we did that to the upper surface. And we got to do this to this tip over here, tangent. So we have that established. And then let's see here how else to handle this stuff. So that's the upper surface taken care of. And we can do a trim right here, TRIM. Click on it, click on that. So now we've broken the airfoil like so, but we're going to need to join it. So basically it's going straight here for the very trailing edge. If you're doing something like a composite wing or something like that, you can do this under curvature without too much trouble, but let's just assume we're going to make this out of aluminum and you don't want to make it difficult. So we've trimmed it and we're going to join it like so. And I don't know, let's just say for the sake of simplicity, we'll leave the bottom in like so. At least the trailing edge does have some thickness. It'll be an 1/8 inch thickness. You can modify and make this straight as well. Like say you had a hinge line over here, you could definitely connect a line like so. But we'll get rid of that. So now the thing has thickness, and now we can go back and grab the lower part of the airfoil, like so, bring it over. We have that, and now we're going to grab the upper. So you'll have two lines, and you have a blunt trailing edge. You can do things like a little wraparound, but hopefully that makes sense. I'll zoom out and try to zoom in. So you can kind of see that in 3 dimensions. So we're going to want to do the same thing, same network surface, lower, trailing edge, lower, leading edge. It's made it, and then we're going to come back to the same thing. So right click, and you got to be zoomed in to make sure you get that upper curve. There you go. You got the whole surface right there. Now to wrap up the trailing edge, we'll repeat that same command. There's other ways to do this, but curve, we'll just do the same network surface because it's a easy command to use. It's not needed on this because it's not contoured, but if it was, it would help. That command failed because it's really close together, so I clicked the wrong surface. You can do things like sweep around 2 rails, things of that kind of command. There we go. So there is our whole airfoil. And let's just say like you're gonna have like 3 degrees of wingtip sweep going, nose down just to help even more with tip stall. So we're going to do a rotate, which is R-O-T-A-T-E. And we'll take all these guys, including that trailing edge. We'll rotate it about the leading edge here. Okay, we're going to go here, and then we're going to just type in 3. So now you can see like that classic, you know, they call it washout. That's where as you go down the span, the airfoil starts to go more and more nose down. So when it gets to critical angle of attack, it won't stall out. Okay, so we've done all that. We're going to come back with the same lines. But we had to delete the old trailing edge just to make this new one here because they wouldn't have gone along for the ride. At least how I use Rhino. I'm sure you could do like a grasshopper thing to make this all work like magic. But now we have our washout in there and same old command, network surface. If you get it just right, you shouldn't have to move the airfoil here with this double line on the trailing edge, maybe a little bit curve. There you go. So now we have an airfoil with, let's see if we can do right. There we go. And rendered maybe. So you can see that classic, you know, washout on the tip of the airfoil. Going in 3D and go rendered. Let's see if we can throw some materials on this just for some more contrast. I'm still getting used to the materials on Rhino 8. I'm more used to them on 7, or sorry, 5. There we go. So we got this guy, and we want the lower surface. I'm going to apply a material. We're going to add a new material. Let's just say metal. There we go. So it's like chromed and reflected, and you can see what that looks like. The bottom may have not have taken, it might still be white. So that's an option. And go back into it, maybe add some more metal options. Let's see here, color. Let's go for like copper. There we go. So that rendering is like really good, sharp looking. For some reason, the reflection isn't showing. I think it's like to do with the lighting settings, but that shows how that works. So there's your airfoil here. What else can we do with this thing? We can do a tip closeout. And for that, honestly, network surface would work. There's a closeout command too. Let's see if I can find it. Since this thing should be planar, it's not like going in all 3 axes. It's only going in 2. So surfaces and surface from planar curves. There we go. Curve, curve, and a curve. So there you go. So we made a tip. Make a root one. So a curve, curve, and the trailing edge. So that's all there. And we'll do the network surface on the trailing edge. Curve, 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 zoom out, zoom in, curve. So yeah, there you go. So now everything is all surfaced and you should be able to do a create solid. And that's the command right there, create solid. Highlight everything. And now this should be seen as an actual solid object. Like if you want to go 3D print this or send it off to something that's solids, you can work with surfaces. Now this is all done flat, but if say you want to get dihedral on this thing, do another rotate, say 3 degrees of dihedral, rotate. So we're gonna, it's easier to work with this stuff planar than kick it up, honestly. Like doing the washout on plane on this method isn't bad, but throw the dihedral in there, it's just a lot going on. So we're gonna go click on leading edge, and then we'll go to whatever axis is correct for that. So we'll go this way, and it would actually be negative dihedral, so we're going to do -3. So there we go. And then you can do like a mirror. And we'll go in and try to go grid. Make sure the grid is on. And you'd have to like patch up the middle here somehow, like, cut it and bring it back together. But there you go. That's your light sport Scimitar wing with a 65 415 at the root and a 63 618 at the tip. 3 degrees of tip washout. So forth, we're 55-inch root chord and 30-inch tip chord. So that's just showing the whole thing and the power of Rhino. Now from here, this could be like your master loft file. This could be created as a step file or whatever you need. And you can send it out to other CAD systems that are maybe not as friendly with the contours as Rhino is. And you can go make mechanical engineering drawings for like the skins and so forth and cut it up from there, or you can keep trucking away in Rhino. But yeah, it definitely shows the aerospace potential of the Rhino software. I know it's very common in boats. The marine industry uses Rhino. I'm surprised aviation doesn't use it just because of the power of freeform contours. There's a lot of other softwares out there where doing something like this would be like pulling teeth out. But hopefully this will help you with your project. And don't forget to like and subscribe if this has helped you at all understanding Rhino and making aircraft parts. And I'll try to do a couple more series on this, but this should give you a good comprehensive idea of how to make a wing in Rhino, whether it be for radio control all the way up to some sort of certified aircraft, just making the contours. So best of luck. Thanks.